Hi.
Weren't expecting that, were you?
Yeah, I planned that.
All right. As you can see, I'm wearing the exact same thing as yesterday because I thought it looked so good in it. Why not wear it 2 days in a row? It's not that I just immediately started recording a lesson after our lesson yesterday. Not that at all. So here we go. We're going to jump right in to the next lesson. Since you didn't have any homework, we can just go through it. I can assign your homework because you best believe you have homework today. And then we'll wrap it up. So, it says use the fundament. This is just a review from yesterday. Use the fundamental counting principle, aka multiply the number of possible outcomes from one event and another to find the total number of outcomes in each situation. So, number one, choosing north, south, east, or west on one of the 50 states. How many outcomes are there for choosing north, south, east, or west? 4. How about one of 50 states? 50. So that would be 4 times 50. Okay, so you could choose North Georgia, or East Wisconsin, or even South Hawaii. So 1 out of 200 would be the probability of randomly choosing one, but all it says is find the total number of outcomes, so we don't need to find any probability. There'd be 200 outcomes in number 1. Picking a day of the week and a month of the year. How many days of the week are there? Yes, and you should be participating in this. Pretend like I'm just talking to you right here. It's not silly. Why do you care what I had for lunch? Mind your own business. Stop looking at me like that, Valentina. And there are 7 days in the week, and there are, you got it, 12 months in a year. So 7 times 12 is 84. Choosing vanilla, strawberry, chocolate, or mint ice cream with fudge, butterscotch, strawberry, or whipped topping. How many options is that so far? 16. In a cup or a cone. So you could have all 16 of those options in a cone or all 16 of those options in a cup. So it doubles to 32. Okay? I think we can just move on from here. It's weird. All right, so how can you predict the outcome of future events? Well, we've talked about this essential question all unit long. You can do simple probability. You can do a simulation. You can act it out. Yeah, lots of different ways you can do. What will we learn today, however? To find a permutation. To use permutations to find probabilities. So, the number of permutations of 3 classes would be 6, aka the number of possible outcomes. It's just a big word for number of possible outcomes. So let's look. Julia is scheduling her first 3 classes. Her choices are math, science, and language arts. Use the fundamental counting principle to find the number of ways Julia can schedule her first 3 classes. Well, there are 3 classes, correct? We could do math, science, language. We could do math, language, science. That's 2. We could do science, language, math. I could count them all out, but there's going to be how many? 6. You have 3 choices for your first one. You have 2 choices for your second class. And then you'd have 1 choice for your third class, right? Let me find out. Where's my... Worked during the meeting yesterday, so I want to see. Where's my options? I can't find my marker. Full screen mode. It's creepy. Made me humongous. Dang. I could go. Oh, I really wish I had that. Really wish I had that. Ooh, a laser. Oh, snap. Y'all, look what I just found. Oh, look what I just found. All right, so I won't be able to write on this, and I don't want to change around websites to go to that free. There's a free whiteboard, but I won't do that. Sorry to waste all that time. If there are 3 choices for the first one, right? You could choose math, science, or language. Let's say you chose math. Of course you would. Then that leaves how many? 2. So then you choose language. At least I would. And so then that leaves only 1 possible choice. You can choose any 3 to start, but then it's going to limit you to 2, and then it's going to limit you to 1. So that is 6 permutations of 3 classes. In other words, 6 possible outcomes for this particular scenario. Dang. I'm going to do that probably like way more times than I would have hoped. So there are 6 possible arrangements or permutations. So let's look at our first example. I love this laser, guys. Babe, look at this laser. Yeah, get up. Walk over here. How cool is that?
Or it leaves you?
What?
Leaves you? Or should have done?
Oh, it's just a laser. There are 5 people on a bowling team. If they bowl one at a time, in how many orders can they bowl? If you wouldn't have seen that first example, this would take you forever to figure out. You could say, okay, there's 1, 2, 3, 4, 5, or you could do 1, 2, 3, 5, 4, or you could do 1, 2, 4, 5, 3, or you just have to make a humongous list. But let me ask, of the 5 people, how many can you choose to go first? Or how many are you choosing out of to go first? 5. Okay, so once I really wish I could write with this laser though. That would be the best. Notes? Nah, that's stupid. Oh, this is like from the PowerPoint. This isn't even, I thought this was from my screen recording stuff. Sorry, I just really wish I had oh. No, thought I found it, didn't. Okay. After you've chosen the first person, there's only 4 people left. So the options you have for your second choice are limited to 4. So 5 times 4 is 20. And after that, you get 3 options for your third. So 20 times 3 is 60. And then after that, you have 2 options for who's going to go fourth. So 60 times 2 is 120. And then you have that last person who's just going to be last. Okay. And that would be 120 still. So our answer is 120. I really wish I could have written that out for you guys. But you can write down what I'm saying. Or maybe my sweet wife, when she's editing this, will have put it in already, and what I'm saying will make no sense. We'll see. An ice cream shop has 31 flavors. This is a total ripoff of Baskin Robbins, right? Doesn't Baskin Robbins have 31 flavors? I'm pretty sure. Carlos wants to buy a 3-scoop cone with 3 different flavors. How many cones could he buy if the order of the flavors is important? So he's like, oh, I am not eating chocolate first. I'm not an animal. I'm eating that second. And don't even think about putting my mint chocolate chip on the bottom. That's got to go first. Are you insane? So he's very particular on how he wants his ice cream scoops. Carlos, right? So there are 31 choices for the first scoop. That's a lot of choices. There are 30 choices for the second scoop because you've already used one of them. He wants them all to be different. Let me use my laser to point that out. Different. And then after he's chosen 2 of them, there's 29 left. So you literally have to say 31 times 30 times 29 is blah-diddy-blah-diddy. Okay? Carlos could buy 26,970 different cones. Unbelievable. That's a lot of ice cream possibilities. Okay, you try one. 15 students are running for 7th grade student council. In how many different ways can the president, vice president, and secretary be chosen? Out of 15 students. Y'all think about that for a moment. And pause. Give yourself some time. Okay, so that should have given you enough time. If there were 15 students and there are 3 different positions that they could be in, well, for president, you could choose anyone out of the 15. For vice president, you have 14 options. And then for secretary, you have 13 options. So you multiply all those together, 15 times 14 times 13, and you get 2,730. There are 2,730 possible ways for the president, vice president, and secretary to be chosen. I bet you would not have thought about that. And again, if you would have tried this at the beginning without knowing how it worked, and you're trying to make lists, you would have to list 2,730. That's crazy. So this is why probability comes in handy. You want to know your odds? There you go. All right, so how do you read this again? It's not find P83. It's find the probability of getting an outcome of 8 or 3. I don't know what they're talking about, but that's what it says. Find the probability of getting an 8 or 3 is 8 times 7 times, what? What is it talking about? 8 things taken 3 at a time. This is new to me. I've never seen it expressed this way. So, hey, we learned something together. High five. Good job. So I guess this is saying find the probability of getting 8 things if you take 3 at a time. Wow. I love how they just like expected you to know that. That's crazy. So find the probability of getting 7 things if you take 2 at a time. So here it was 8 things taken 3 at a time. So we did 8 times 7 times 6, because 8 for the first thing, 7 for the second, and 6 for the third. So here there would be 7 for the first and 6 for the second, which would be 42. That one was kind of interesting. So hopefully we'll let us look at another one like that. Okay. In fact, I might open up the book for that. Might not be a bad idea. Let's move on. Ashley's MP3 player has a setting that allows the songs to play in a random order. She has a playlist that contains 10 songs. What is the probability that the MP3 player will randomly play the first 3 songs in order? Okay, so she has 10 songs. You would think it's not that unlikely that it's going to play the first 3 in order, but it is. I mean, just the fact of it choosing the first song first is 1 out of 10, right? So you have 10 possibilities for the first one. The way you'd write this, I wish they would have done this example first. That would have made a lot more sense. You would say the probability of out of 10 things, 3 at a time, taking 3 at a time. So we have 10 songs, and we're talking about 3 songs being played in order. So you would say, well, there's a possibility of 10 for the first song, and then 9 for the second, and then 8 for the third for outcomes. You multiply all those together, you get 720. So it's 10 songs chosen with 3 chosen. So there's 720 different ways to play the first 3 songs. So then it says, what is the probability that the MP3 will randomly play the first 3 songs in order? It's interesting. Well, the first song is number 1, so there's only a 1 in 10 chance. The second song, it's only a 1 in 9 chance. So it's going to be, I mean, there's only one combination for it to play in that order, right? It's going to be 1 out of 720. So that's the probability. And if you made that percent, let's see if they made that percent. They did not. If you were to make that a percent, it would be very, very small, like 0.00. It'd be less than 1%, obviously. it would be less than point. Well, let's see. Sorry, I'm just trying to do this in my head. Because if you were to simplify 720 down to, let's say it's 700, we'll round it. Divide that by 7 to get 100. So 1 divided by 7 is 0.1. Yeah, so it's going to be like less than 0.1%. That's crazy. All right, let's look at this example. All right. Let's look at this example. And this one, I'm not going to lie, it took me a good minute to figure out because it made no sense to me. I love how they do this sometimes. They have this like super simple example over here, then they're like, bam, do this one. It says consider all the 5-digit numbers that can be formed using the digits 1, 2, 3, 4, and 5 where you don't use any twice. In other words, they're people. You can't use, if they're bowling, you can't have the same person go twice. Find the probability that one of these numbers picked at random ends with a 5. Okay, so first we need to know the total amount of possible outcomes. And it works the same way as the bowling example. The first number, you have 5 options. The second one, you have 4, so 5 times 4. The third one, you have 3, so 5 times 4 times 3. The fourth one, you have 2, so 5 times 4 times 3 times 2. And then the last one times 1, so that's 120. If you do 5 times 4 times 3 times 2, you get 120. So there are 120 possible outcomes, just like with the bowling example. Now, find the probability that one of these numbers ends with a 5. So here's what we need to do. We need to figure out, well, for each number chosen first, how many possible outcomes give you 5 at the end? So let's say we chose 1 first. Okay? How many possible outcomes are going to have 5 as the last digit? Well, for the next number after 1, how many choices do you have? Don't say 4, because there's not. You can't choose 5. 5 has to go at the end. So you have 3 choices to go after 1. To go in the second number. To go in the third number, you're going to have 2 choices. So right now we're at 3 times 2. And for that fourth number, you'll be left with only 1 choice. So 3 times 2 times 1, that's 6. So that means that for each number chosen to go first, there are 6 possible outcomes that will give you 5 as your last digit. And we can't start with 5 because it's the last digit. So there are 6 possible outcomes for 1 to end in 5. There are 6 possible outcomes for 2 to end in 5, and for 3 and for 4 to end in 5. So if you do 6 times 4, that is 24 out of 120. We have to simplify probability, so that's where they got 1/5. You could say that you could see that 24 and 140 or 120. I honestly would not have realized that 24 goes in there, so I would have divided by 12 and gotten 2/60. I'm sorry. Yeah, 2/60. Wait, what? Dang it. Dang it, dang it, dang it. 24 over 120. That's 12. What? Oh, stupid me, stupid me. If you divide 120 by 12, oh my gosh, my brain. Good luck editing this. So we have to simplify. And I would have noticed that 24 and 120 share a common factor of 12, so you divide both sides by 12, you get 2 over 10, and 2 over 10 was simplified to 1 over 5. But that's the same thing as 20%. So that one is a challenge for sure. So the first place you should always start when things are challenging is how many possible outcomes. And then you just kind of have to use some problem solving skills to break it down. So let's see if we see another one like this. A swimming event features 8 swimmers. If each swimmer has an equally likely chance of finishing in the top two, what is the probability that Yumi will be in first place and Paquita in second place? So like I said, the first thing you have to do is figure out, well, how many possible outcomes are there with 8 swimmers finishing in the top two? Okay, so 8 things, choosing 2. 8 things, choosing 2. So if you're choosing 2, that means the first option has 8, the second one has 7, so that's 56. That's where they get the permutation. So this is just like the other examples. However many you have, that's how many options you have for the first choice. Subtract 1, that's how many options you have for the second choice. Subtract 1, that's how many options you have for the third, and so on. So there are 56 possible arrangements. Since there is only one way of having Yumi come in first and Paquita second, it's 1 out of 56. There's no other way for that to happen, right? Unless you included like third place, well then that would definitely add more, but there's only 2. We're only doing 2. Okay, so let's look at this one together. A school fair holds a raffle with first, second, and third prizes. 7 people enter the raffle, including Mark, Lily, and Heather. That's nice. What is the probability that Mark will win the first prize, Lily will win the second, and Heather will win the third? So they are talking about 3 things happening. Okay, 7 people enter. So out of 7, remember over here, out of 8 people, 2 are chosen. So out of 7 people, 3 are chosen. So the first person will have it, there's 1 out of 7 chance. The second one, 6. So 7 times 6. The third one, 5. So 7 times 6 is 42 times 5. Let me do that super quick. I should be able to do it in my head, but it's been a long day. 210. 210 possible outcomes. So what is the probability that Mark will get first, Lily second, and Heather third? There's only 1. How can you have that 3 combination in another scenario? You cannot. So there's only the one way that can happen out of 210 possible outcomes for the 7 people. Okay, so we figured out how many possible outcomes, and then we see that that's just a very unique, where they're saying there's only 1 person going to be first, 1 person going to be second, 1 person going to be third. So I think we should look at an example in the book super quickly. I know the screen's a little weird because of the way I'm capturing it, but just 1 second. Let's find some like this. Okay. Let's start off with number 2 here. See if I can zoom it in a little bit. Yowza. Perfect. Number 2 says find the value of P 5, 3. And remember we learned together earlier that meant find the probability that out of 5 things, 3 are chosen. So if there are 5 things and 3 are chosen, the first choice has 5, the second choice has 4, and the third choice has 3. So that would be 60, just like the beginning of our bowling problem. Okay, now let's see if we can do one. Let's get rid of the answers. This one is just like our example, so that's kind of easy. Let's look at how many ways can the 4 participating bands perform? Okay, because I showed the answer to that one, we have to do a different one, sorry. All right, let's look at 21. That's what we're going to do. 21. It says a child has wooden blocks with the letters shown, G-T-R-I-E. Find the probability that the child randomly arranges the letters in the order tiger. Okay, doesn't sound very likely, but let's see. First of all, how many possible outcomes are there? you're going to start to recognize patterns here. There are 5 blocks. So how many possible outcomes are there? 5 for the first option of letters, 4 for the second, 3, 2, and then 1 for the last one. So 5 times 4 times 3 times 2 times 1. We've already learned from the bowling example that it's 1 out of 20. There are 20 possible outcomes. The odds that they put the T and then the I and then the G and then the E and then the R is 1 out of 20. That's simple. It is that simple, not that simple. Okay. Listen, this lesson gets a little more difficult for sure. What I want you to do for your homework is, and I'm showing you for all you clowns that forget, to go to resources for the lesson, go down to worksheets, and you're going to do the skills practice page. Okay, so first it says find each value, use a calculator if needed. Sure, you can use a calculator. I don't think you will need it, but you might for ones like, let's say this one. That one's kind of confusing because there are more on the second one. I wonder what they say for that. Good luck with that one. We'll make 6 a little bonus. How about that? Okay, so your homework is going to be lesson 6, skills practice. And that's our lesson. So if you have any questions, feel free to ask, but you have the book as a resource, you have the tutor videos as a resource, you have the resources from the website that I would like for you to exhaust first, and then come to me. But I am here if you need me. All right, have a great day, and I will see you Thursday. Bye-bye.